So we have the graph of y equals f of x right over here. And what we want to do is figure out the limit of f of x as x approaches negative 4. So what does that mean? Well, a limit is saying what is my function approach as the input of that function approaches, in this case, negative 4, as the input approaches a value. And as we see in this example, the function doesn't necessarily have to be even defined at that value. We can see f of negative 4. You go to x equals negative 4, and you see that f of negative 4 is undefined. So this is not defined. But as we'll see, even though the function isn't defined there, the limit might be defined there. And actually, it could go the other way around. Sometimes a function is defined there, but the limit is not. And we'll see that in future videos. But let's just get an understanding here. What's going on as x approaches negative 4? As x approaches negative 4. From values greater than negative 4 and from values less than negative 4. Well, let's first think about values greater than negative 4. So when x is negative 1, this is f of negative 1. This is f of negative 2. This is f of negative 3. This is f of negative 3.5. This is f of negative 3.9. This is f of negative 3.99. This is f of negative 3.999999. And so you can see the value of our function as x gets closer and closer to negative 4 from values greater than negative 4 seems to be approaching 6. And let's see if that's true from the other direction, from values less than negative 4. So this is f of negative 7, f of negative 6. This is f of negative 5. It looks like it's around 7. This is f of negative 4.5, f of negative 4.1, f of negative 4.01, f of negative 4.000001. It looks like it's getting it's going to be a little bit more than 6. So it seems as we get closer and closer to 6, as we get closer and closer to x equals negative 4, the value of our function is approaching positive 6.